Hi there. Well, this is going to be the last section we'll do before we take the Chapter 10 test. And Section 10.8 will be a part of Chapter 11. It fits better. So again, this will be our last section before we take the test. And what this is over is solving radical equations. And in this section, we'll learn how to solve equations where the variable appears in the radicand. So we've got an x inside the radical. Now, in order to solve these types of equations, we're going to use, there's a new principle we're going to use called the principle of powers. And it's actually pretty much the same thing that we've always done, but let's go ahead and go through it. It's just that, okay, if a is equal to b, all right, then a to the n is equal to b to the n for any exponent n. So in other words, if you have an equation, you can square both sides as long as you square both sides. You can cube both sides as long as you do that to both sides. You're allowed to do that. So we have an example. So if x is equal to 3, we could square both sides. So you square the x, you get x squared, you square the 3, and you get 9. And so it's still equal to each other. And again, and make sure you do this to both sides. Just like if you add a 3 to one side, you add a 3 to the other. You divide by a 2, you divide by a 2. It's the same idea. It's just that now we'll be squaring or cubing or taking it to the 4th power in order to solve these radical problems. Now, one thing I want to caution you, it's very important, not all your solutions will work. So when you're done, it's very important that you substitute your answers back into the original and make sure that the left is equal to the right, and also make sure that if your index is even, you cannot have a negative inside in this chapter, and we'll deal with the negative inside in the next chapter. But for right now, you cannot have a negative inside, and you need to make sure that the left is equal to the right. And all this stuff will come out as we go through these examples. All right, so let's go through some examples. Let's start. Okay, we have the square root of x minus 3 is equal to 4. Now, some of you may be able to, to figure this out without actually going through the steps, but we're going to go through the steps. The first thing, get the radical by itself on one side. So in other words, I need to get rid of the subtract 3. So you need to isolate your radical. So I'm going to add 3 to both sides. So that leaves me with the square root of x on the left, that cancels out, as being equal to 7. Now, we're almost done. Once you have the radical by itself, then to get rid of that square root of x, I square both sides. Okay. So what I've done is I've created 2 of these inside, which means this is equal to x. So I come up with a solution of x equals 49. So again, when you take a radical and you square it, you're creating 2 x's inside here. And that's what we needed, was 2. And so they come out, and you end up with 49. Well, and again, it's important to check. So let's go over here and check. We're going to put 49 in for the x, minus 3 equals 4. And simplify that for our check. I just substituted in the 49 just to make sure. This is 7. Square root of 49 is 7, because 49 is 7 times 7. 4 equals 4. It checks. So our solution is x equals 49. So it works. So again, we're just isolating the radical. And then we either, if it's a square root, we'll square, and cube root, we'll cube. But let's go ahead and let's look at our next one. Again, let's get the radical by itself. So I'm going to subtract 5. So we end up with the square root of x equaling a negative 2. Now, some of you may say, okay, the square root. Square roots or fourth roots or sixth roots will never be a negative. Remember, this is the principal square root. This means it has to be positive over here. But let's assume, okay, so it's actually no solution because you can't take a square root and get a -2. But let's go ahead and go through the whole process, go through what we did over here, and then we'll come back and you'll see during the check that it doesn't work. But a principal square root and even cannot be equal to a negative. But we're going to go through the process. We're going to square both sides like we did up here. So once we get to here, we'll square both sides. And we will end up with the square root of x squared. That means we're going to have 2 of the x's now is x. Okay. Now, this also, in order to go from here to here, in case that's confusing, remember this is x to the 1/2 squared. Okay. Those two statements mean the same thing. It's kind of a review. Power to a power you multiply. 1/2 times 2 is 1. Okay, so we end up with x to the first is another way of looking at that. Then we square the -2. -2 times the -2 is a +4. So we come up with x as being equal to a +4. Let's go back and check. So here we're going to put in our square root of 4 for our check. I'll go ahead and copy the problem down. So we'll have the square root of 4 plus 5 equals 3. Well, the square root of 4 is 2. 7 does not equal 3. Therefore, that is not a solution. This is no solution. No solution for this one. Okay? All right. Let's try another one. So again, the first step is to isolate our radical. And on number 3, the radical is already by itself. We didn't have to get rid of a 5. We didn't have to get rid of a -3 so that the radical was by itself, you know, before we squared it to get rid of that square root. So we're going to go ahead and we're going to square both sides because the radical is already by itself. Since it's a square root, I'll square. So this right here will cancel out the square root. And we end up with just 2x plus 3. So if you square a square root, it disappears. It becomes a power of 1. Okay. Just this exact same idea right here. Then whatever you do to one side, according to our principle of powers, if you square the left to get rid of the radical, you need to square the right. So we get 25. So now we will solve this for x, since we got rid of our radical, and then we will check it. So subtract 3. Okay, 2x equals 22. Divide by 2. X equals 11. So before we say that's a solution, we're going to go back and do a check, put it into the original, make sure that we don't have any negatives inside of a radical, and we need to make sure that the left truly does equal the right. Excuse me. So let's go ahead and do our check. Does 11 work? So we've got the square root. I'm going to go ahead and copy it over the original, and I will put an 11 in for the x. Okay, this is 22 plus 3, which is 25. So 22 plus 3 is 25. The square root of 5 is 5. it checks. So our solution is x equals 11. So on these first three, you isolate your square root, okay, in our first step, unless it's already isolated by itself. And then once that radical is by itself, then we square both sides. That gets rid of the square root. Why? Because square root is a 1/2. If you square it, 1/2 times 2 is a 1. So you end up with a power of 1. And then once you have your solution, and once it's solved, you need to make sure that you check, because sometimes your solution is correct, sometimes it's not. So again, it's really important that you check with these. Okay. All right. Let's go ahead and look at this next one here. Now, again, just like what we did before, we're going to get the square root by itself. Now, here, we're going to add 13. So I end up with 2 square roots of y equaling 20. So again, I'm just concentrating on getting the radical by itself. Now here, the 2. There's 2 things you can do here. You could divide both sides by 2, and that's actually what I would do, because if you divide by 2, because 2 goes into 20 evenly. So I would divide by 2 in order to get this radical by itself. Now, for some reason it froze. Okay. Now, do you have to? No, and we'll look at that, because sometimes if this does not go into the other side evenly, then I would leave this. And how do you deal with it if you leave it when you square both sides? But for right now, I'm going to divide by 2. The next problem, we're going to leave it. And let's see. So we have a square root of y by itself equaling 10. Okay? So I just isolated. I add 13, divide by 2. Once you've done that, we'll square both sides to get rid of our radical. Okay. This leaves us with y, because the square root and the squared cancel each other out, and you're left with a power of 1. 10 squared, it's not 20, remember that, it's 10 times 10, which is 100. Okay, we have to do our check. So let's go back to the original. We have 2 square roots of y minus 13. We need to make sure that we can put 100 in. Now, the square root of 100 is not a negative square root in there, so the square root of 100, simplifying this, is 10, because remember in PEMDAS you do the exponents, and then you multiply. So we did the exponent of 1/2, power of 1/2. This is considered a power. You get 10. 2 times 10 is 20. Minus 13 equals 7. So you do the square root, simplify it. 2 times whatever you get there, which is 20, minus 13. So we get 7 equaling 7. It does check. So our solution is y equals 100. So this had an extra step, just one extra step with that 2 is all. And the only reason I divided by 2 was because it went into this number over here evenly. You know, if it doesn't go into there evenly, you're dealing with fractions, which isn't as fun. So let's look at our next one. Okay. I have the radical. I did not have to get rid of a number like 13 here. I didn't have to do that. But I do have the 8, just like I had the 2. If I divide by 8, c divided by 8 creates a fraction over there, which is something we don't want. So when you're multiplying a number out here, you can leave it and then square both sides. So we're going to go ahead and leave that. These are large enough that I can, and we're going to square both sides. So how do you square the left-hand side when you have a number times your radical? Since we didn't get rid of it like we did on this one. All you do is you square the 8 out front, which gives you 64. So the number is squared, and then the square root of c squared is c. So 8 square roots of c squared, you square the number in front, and then you square your square root, and the squared cancels out the square root, so you're left with just a c. So it's really not that bad. So looking back at number 4, coming back to this step, if you would have left the 2 there and squared it, you would have had a 4 out front. That would have been a y, and that would have been a 400. 400 divided by 4 is 100. You would have ended up with the same answer. I just encourage you that if it goes into there evenly, go ahead. Then you're dealing with smaller numbers, and that's a lot nicer. Well, let's finish this. Since we squared our 8, it was outside of a radical, so we actually had to take 8 times 8. And then the radical disappeared. Okay, when you square square root, it disappears. And then c squared. All right, well, rats, we've got a c squared. So I know that in order to solve this, because of the squared, I've got to set it equal to 0 and factor. So, this factoring never leaves you. Once, after chapter 5 and 6. So what we'll do is, setting it equal to 0, I'm going to move the 64c to the other side. And the reason is I want to keep my highest power positive. So I'm going to move this over, minus 64c. So on the left, I have a 0. Over here, hopefully by now that you cannot combine those. They need to stay separate. This is c squared minus 64c. Factoring. Well, the first step in factoring is to look for the greatest common factor. And the greatest common factor is something that you could take out of both of these terms, which would be a c. So I will take out, I'm going to come up here, right up here now. I'm going to have 0 on the left. On the right-hand side, I'm going to take a c out. Well, c times c gives me c squared. And then I want a minus 64. C times a minus 64 is a minus 64c. You're actually done factoring, so it really wasn't too bad. And the reason I'm done is because I don't have a squared or a cubed or something like that inside. So using your the property of a zeros, zero property principle means that either this has to be 0, that number, or that number has to be 0 in order to take a number times something to get to 0. One of those has to be 0. 0 times a number is 0, or a number times 0 is 0. So either c equals 0 or c minus 64 equals 0. Great review. Add 64 to both sides over here. Since this one is done, and we just have to check it now. We add 64. Okay. We have either 0 or we have 64. Maybe both of them will work. Maybe only one will work, or maybe neither one of them will work. So we're going to go back to the original and do our check now. So we're going to go do our check. We're going to take our original. There was our original. We're going to put both of our numbers in. Let's try putting in 0 first. So 8 times the square root of 0. Well, the square root of 0 is 0. 0 times 0 is 0. Checks. So C works. Yay. What about 64? Well, 64, if we put that in for C, I'll just go ahead and go over here. 8 times 64. Is that true? Well, you do your powers first. Even a power to a 1/2 is still a power. Then you take 8 times that. 64 equals 64. Both of them check. So both of those are solutions, 0 and 64. Okay, all righty. Well, let's look at something that maybe isn't a square root. How do you handle a radical that is, like a cube root, for instance, on number 6? Well, if you look here, I have the cube root as equaling a -4. Well, looking back at your number 2, we had a square root equaling a -2, and we said right away that's not possible, it's no solution. But that was a square root. That was an even indexes, or even indice, cannot be negative. But an odd can be negative. So this one does have a possibility, a strong possibility of having a solution because that is odd. Well, we'll go through the same steps. We're going to isolate the radical, which it is isolated. Once we've isolated it, rather than squaring, we're going to cube both sides, right? Really for the same reason, this is a power of 1/3. A power of 1/3 times 3 is 1. So we cube both sides to get rid of the cube root. It cancels out and you end up with a 1 power. So we're left with y plus 1 equaling -4 cubed is a -4 times a -4, which is a +16, times a -4 is a -64. When you have an odd, the negative stays when you have an odd power. Now we subtract 1. Y is equal to a -65. Well, we're going to check it. We're going to make sure. Okay, so we're going to put this back into the original for our check. So we've got the cube root of y plus 1 equaling -4. Let's put in our 65. -65 plus 1. That -65 plus 1 is a -64. We're like, this is the parentheses part of the PEMDAS. Then we'll do our exponent, which is this to the cube root of 64 is a -4, because a -4 times a -4 times a -4 is a -64. If you have 3 of them, you get a -64. So I have 3 4s in here. And the negative just comes down if you have an odd. So it checks. So there's your answer. So it does work. All righty. So, you isolate the radical, and rather than squaring it, you cube it. It's the only difference. Let's try number 7 here. We're going to go ahead and we have to isolate our radical. Even though it's a 4th root, same steps. So this is going to give us the 4th root of 3x plus 1 equaling, I'm going to add a 4. I didn't give myself a lot of room, and get 3. Okay. +4 and a -1 is +3. Now, rather than a cube root, or rather than cubing it or squaring it, I'm going to take it to the 4th power. Now that I have it isolated, I take it to the 4th power to get rid of this 1/4 here. And then I will take this to the fourth as well. Whatever you do to one side, make sure that you do to the other to keep it balanced. All righty. This becomes 3x plus 1. The radical disappears, equaling 3 times 3 is 9, times 3 is 27, times 3 is 81. Okay. Oh, it's going to be a fraction? Really? Oh, well, that's okay. We can deal with a fraction. You guys are okay. So then to solve this, I don't have a squared here, you know, so I don't have to factor it. All I need to do, or a cube, I just need to get the x by itself. Subtract 1, 3x. I'm going to come back up here. So I'm just going to come up here and finish solving it. Divide by 3. X equals 80/3. Yeah, well, let's just leave it as 80/3, and when we check it, it's fine. It'll check out really nice. So let's check our answer. So I'm going to put this back up into the original. The original being the fourth root of 3x plus 1 minus 4 equaling a negative 1. Now, we'll put in 80/3. 3 times 80/3 plus 1, subtract the 4. The nice thing about this 80/3, you guys, it wasn't so bad to put it back in because the 3's cancel. It's 3 over 1, so they cancel. So we end up with the fourth root of 80 plus 1. So this ends up being the fourth root of 81. The fourth root of 81, if you break this down, you're going to have 4 3s, because 3 times 3 times 4 of these give you 81. So this is a 3. And sure enough, negative 1 equals a negative 1. That's a negative 1, negative 1. So it checks. 80/3 is your answer. It wasn't bad to check, just so you know, just it canceled out. So it was okay. All right, perfect. So again, we just isolated our radical because it was a fourth root. We took it to the fourth power both sides, and then we got the x by itself, and then you check it. Okay, it looks a little different. So we actually have 2 more types to go through. Here I've got a radical on both sides. So this really isn't so bad, you know, especially because they have the same index. So if you're given something like this, you guys, just square both sides. Okay? And if you square a radical, that radical will disappear. If you square a square root, the square root disappears. And it disappears on both sides. Pretty nice. So now that we don't have a squared in the a's or anything, so you just get the a's by itself and then you're done. So choices here, either subtract 4x or subtract 3x. Let's subtract 3x. Let's work with a positive. So 4 equals a plus 3. 4a and a minus 3a is a. Subtract 3. No. A is 1. And we have to do a check. And I'm sorry, you know, I'm kind of running out of room. I think maybe I could put the check right here, but I don't think I'm going to copy it over. I'm just going to go ahead and put the 1 in for A. So I'm going to have the square root of 3 times 1 plus 4 equals the square root of 4 times 1 plus 3. So this gives me the square root. 3 times 1 is 3. 3 plus 4 is 7. This is 4, because 4 times 1 is 4, plus 3 is 7. The square root of 7 does equal the square root of 7. It does check. So 1 works. There's your answer. Wow. Well, in case that was confusing, and let's go ahead and let's look at another one that's similar to 8, and then we'll check it and see what happens. Okay, on this one, again, the radicals are kind of by themselves. You got one on the left and one on the right, so we're going to go ahead and square both sides, because I guess you could consider them isolated. So we're going to square this and square this. So if you did have that, if you did have this one over here, you would have to move it to the other side. So, you know, and we're going to deal with some a little bit harder ones. Our last 3 are a little bit tougher. But again, if you only have those 2 radicals, just go ahead and isolate them. And put one on one side and one on the other, and then square both sides. So when you square the square root, it disappears. You end up with 5x equaling 2x plus 3. So then you subtract 2x, and we end up with 3x equaling 3. Okay. And because that cancels out. So then you divide by 3, x equals 1. Okay, does it work? Put it back in. Check. We have the square root of 5x equaling the square root of 2x plus 3. Put in 1. Does it equal 2 times 1 plus 3? This is 5. 2 times 1 is 2, plus 3 is 5. Let's check. So there's your solution. So again, make sure you check. All righty. So, you know, we've talked about if we have a single radical, isolate it. Sometimes you'll have 2, and you need to have them on opposite sides if they're not already. And then you just square. If they'd have been cube roots, you cube both sides. Those are pretty easy. 8 and 9 are pretty easy. Okay? All right. So, last ones. Little bit more algebra intensive here. But we can definitely do this. Okay, 10, 11, and 12. So, I need to get the radical by itself. That first step is the same. And so I'm going to subtract 3 from both sides. And so here I've got 5 minus x equaling x minus 3. Now, when you, okay, the next step is also the same as what we were doing before. We have to square both sides. Now that we have this isolated, on the left, we're going to square both sides to get rid of that radical. So we move the 3 over, so we're isolating our square root so that we can square both sides. When we square the left, it's the same as what we've been doing. But if you square the right-hand side, you have to be careful. This goes back to your chapters 5 and 6, the FOIL method. So when I square the left, I end up with 5 minus x. The square root, if you square a square root, you end up with 5 minus x. They cancel out. But this right here is x minus 3 times x minus 3. When you have 2 of them, rewrite them and use the FOIL method. Do not put x squared minus 9 and be done, because that's not correct. So we've got 5 minus x equaling, using your FOIL, the first times the first is x squared. The outside minus 3x and a minus 3x is a minus 6x. The last times the last is plus 9. Okay. Just got a lot of shade there for real quick, all of a sudden. Oh well. Let me move this out of the way. And wow, maybe I can move this into the sunbeam. I don't know. Oh, here. Let me move my table over just a second, you guys. All of a sudden the sun went down and I have too much shade. Here, oh, I know. Huh. No, I thought maybe it was my water. Okay, well, there we go. I just moved it over here. So again, we subtracted 3 from both sides, but then we could not combine those to get a single term. So then when we squared them, we knew this one was easy. We've been doing that. But this one, you had to use the FOIL method, and you get this. So just like previously when we had that 8c equals the c squared, or the 64c, whenever you have a squared, you're going to need to set it equal to 0 and factor it when you have a squared. So that's what we're going to do now. So we're going to have, we're going to subtract 5 from both sides. Okay. And then we're going to add an x to both sides. So we end up with 0 equaling x squared minus 5x plus 4. Alrighty. And now, before the sun goes all the way down, I'm going. I think I can get this done before I lose my little spot here. We're going to factor this right here. I wonder if I open up the window. Okay. And when we factor this, we look for what's in common, and there's nothing in common between these 3 terms. So we say, okay, x times x equals x squared. 4 times 1 gives you 4. So if I take a -4 times a -1, I end up with a +4 when I multiply. -4x and a -1x is a -5x. Okay, so people automatically always just think 4 of 2 and 2, but 4 and 1 also multiplied together give you 4, not just 2 and 2. So my 2 possibilities are then, if this is 0, it delayed. Okay, if this is 0, x is 4. If this is 0, x is 1. So do both of them work, or maybe only one works, or none of them work? So we need to put this over here. Okay, so here we're going to try the 4 and the 1. We're going to do a check. So it wasn't too bad. I mean, the factoring wasn't too bad. So we're going to put it back up into here. We're going to do our check. So we have 3. I have room to write it down. 5 minus x. We're dog sitting, and the dog's not happy, but he's just going to have to wait. So we have 3 plus the square root of 5 minus 4 equals 4. So what we're going to do is we're going to try the 4 first. We're going to put the 4 back in for the x's. This gives me 3 plus the square root of 1. 3 plus 1, because the square root of 1 is 1. So 4 equals 4. So we do know that one of our solutions that works is the 4. Let's try the 1 and see if the 1 is going to work. I'm going to move this over just a bit. We're going to put 1 in for our x's. 3 plus the square root of 5 minus 1 equaling 1. So we're going to put in 1 now. 3 plus the square root of 4. 3 plus the square root of 4 is 2. 5 does not equal 1. So 1 is not a solution. Your only solution is 4. Okay? All righty. So, you know, it wasn't really too bad. I'm going to try to open this door so I have a larger area to work with. So just one moment, please. Sorry about that. No, it's not working. Oh well. Okay, it didn't work, so I'm going to try to move my whole table back. There we go. Oh, all right. Sorry. Okay, what's fine. That worked. Perfect. Okay, let's try this next one here. Now, I have two radicals. All right, and so when you have two radicals, make sure they're on opposite sides. So I've got one on the left and I have one on the right. And on this number 11. So I put here and here. So if they would have both been on the same side, like we're going to look at number 12, you're going to have to move one of them over, just like if you look down at number 12. But on 11, you've got one on the left and one on the right. So what I'm going to do is I'm going to square both sides. So here, I'm going to square this, and I'm going to square this, okay? Now, when I do that on the left, no problem. It's just a single radical, when you square a square root, you're just left with 4x minus 3. But what about the right-hand side? Well, it's kind of like what we did up above with the x minus 3s. You've got two of these, and you need to rewrite it because of that plus sign there. You need to rewrite it twice. 2 plus and 2 plus. We don't use the conjugate. They just stay the same. This statement means the same as this statement. So now we use the FOIL method with this. So we're going to take the first times the first. That leaves you with 4. Then I'm going to multiply the outside. When I do that, I get 2 square roots. I get 2 of these when I multiply those together. Then would you let Casey out, please? I'm recording. And then you multiply these together. It's on the outside, 2x minus 5. Okay, when you multiply the insides, which leaves you with 4. Okay. And then you take the last times the last. Well, if you take this square root times this square root, you're going to, it's like squaring it. It's just like this. Okay. You're squaring it. You'll have 2 of these inside. So when you take this, when you take the square root, I'll do that up here. 2x minus 5 times the square root of 2x minus 5, you end up with 2 of the 2x minus 5s in the radical. Okay? And when you have 2 of something, it comes out. So this, the last times the last, is going to be plus 2x minus 5. So wow, there's some algebra involved there and working with radicals. Now, I still have a radical. So you're going to have to isolate this radical and then square both sides again. Wow, so you're going to have to move here. Let's go ahead and clean it up just a little bit. The -5 and the 4. So I've got this radical. The 4. Bless you. I have the 2x right here. I've got this, and a -5 and 4 is a -1. I just cleaned up that right-hand side. It doesn't really matter the order you put these in. Just make sure you have a plus in front of the 2x, a plus in front of the 4, it's a positive, and a -1. Now you isolate the radical. So we're going to move everything over to the left except for the radical, and then square both sides again. Okay. So really the hardest part is squaring this radical. Okay, so now we're going to subtract 2x, and add 1. I'm going to write this right here. So we have on one side, we have this. And on the other side, we have 2x. 4x and a minus 2x is 2x minus 2. Okay. Wow. So now it's just like number 10 again. You know, we're going to have to square both sides. But the thing is that, okay, I've got that 4 in front. Now, 4 would not go into these evenly, but 2 will go into everything evenly. So you can divide everything by 2 here. So this leaves you with 2. So 2x minus 5. Divide by 2, you get x. Divide by 2, and you get 1. If you hadn't done that, you're going to end up with the same answer. You'll just have to reduce more, and it might be a little harder to factor, but you could do that. So as long as it went into every term, looking down here, if it goes into every term, go ahead and do that. So now I'm going to square both sides. Okay, let's square it. Well, you square the 2 outside. Okay, that's a 4. And now you have to use parentheses because you're getting rid of the radical. Okay, so do use parentheses. Equals x minus 1 times x minus 1. You use your FOIL method. Well, I'm going to go ahead and multiply this out. 8x minus 20. Okay, good job. Equals x squared, the first times the first, minus 1x, and a minus 1x is a minus 2x. Last times the last. And now you set it equal to 0 and factor it. Plus 20. So 0 equals x squared minus 10x plus 21. Alrighty, what multiplied together gives you 21. If I can, that's right. What multiplied together gives you 21, added together gives you a negative 10. That would be a negative 7 and a negative 3. And there's nothing in common. X times x is x squared. 7 times 3 is 21, and I want them both negative. That'll give me the positive 21 and the negative 10. So my possible answers are 7 when that's 0, or 3 when that one's 0. And we have to check it, so we're not done yet. Now I'm going to go ahead and check this on another sheet of paper, because otherwise I'm going to run out of room. So to check this, I'm going to put 7 back into the original. So my original, this is going to be my check. My original was the square root of 4x minus 3 equaling 2 plus the square root of 2x minus 5. I'm going to try the 7. Okay. So if I put 7 into here, I have 4 times 7 minus 3. 2 times 7 minus 5. This will be the square root of 28 minus 3. Square root of 25, which is 5. Let's do this one. 2 plus 14 minus 5 Good job. So far, so good. 2 plus the square root of 9. The square root of 9 is 3. 2 plus 3 is 5. It checks. So 7 is a solution. Okay. Let's now try the 3 here. Scoot this over. We'll go through the 3. Let me move this just a little bit. Okay. So now I'm going to put in a 3. So that gives me the square root of 4 times 3 minus 3 equaling 2 plus the square root of 2 times 3 minus 5. Okay, let's see. 4 times 3 is 12. Subtract 12 minus 3, 9. You get 3. Square root of 3. Let's go to the other side. 2 plus 6 minus 5. 2 times 3 is 6. 2 plus the square root of 1. 2 plus 1 is 3. So they both checked. Both solutions, neither one of them gave us a negative in the radical of an even radical, and the left equals the right. So I think, you know, looking at this problem, oh my goodness, look at all that. Look at all that work. I think the hard part in looking at this, here, I'm going to move this up. I just didn't get that whole problem out of the way. I think that the hard part here is going to be, it's this right here. It's taking 2 plus the square root of 2x minus 5 times 2 plus the square root of 2x minus 5. To me, that's the hard part right there, using the FOIL method. And just remember that when you take the 2 times this, you end up with 2, because you multiply it's out of the radical times what's in front. And then when you multiply the outsides, and when you're doing this, these are going to match, okay, every time. These two are, the outside and the inside will always match. So you end up with 4 of those. Another hard part is when you take the square root of 2x minus 5 times the square root of 2x minus 5, you end up with 2 of these inside, so they come out as 1. And that will happen every time. That radical will disappear. And once you've done that, obviously the first was pretty easy. And then you combine your similar terms, that's where the minus 1 came from. The 2x stayed separate, okay? Then you had to isolate your radical. And it was on the right here, but I put it over here on the left. And I put these over here. And I said, okay, you can divide each of these terms by 2, so I did it. So that's where the 2 came from. And then I square both sides again, set it equal to 0 and factor. So, wow. We're going to try one more and then we'll be done. Let's go ahead and we're going to go through this one. Same steps. All right, I've got my 2 radicals on the same side. One of them has to be moved to the other, because if you look at 11, you had a radical on the left and you had another radical on the right. You need to ask yourself, which one would be easier to move? Do you want to move the square root of x plus 2 to the right-hand side by adding its opposite? Or do you want to move the square root of 3x plus 4? I think I would move the one that has the smallest numbers involved. So we're going to go ahead and move this one over by adding its opposite. Okay, so I'm going to add the opposite. If you have a positive this plus a negative, it adds up to 0. So I moved it to the other side. When you move something to the other side, it changes signs, okay, which it did. It was positive here, it's negative over here. So now then I have the square root of 3x plus 4 equaling 2 minus the square root of x plus 2. So now we're going to take and we're going to square both sides to get rid of that square root. All right, so here we go again. We square the left, no problem. It's pretty easy. The radical just disappears. But when we square the right-hand side, we have to use the FOIL method. Okay, so let's use our FOIL method. Okay, we're going to take first times the first. So we're going to take 2 times 2, which gives us 4. I'm going to move it down here. And the 3x plus 4 stays, because that just got rid of the radical. Now, I'm going to multiply the outside. When I multiply those together, I get a negative 2, because I take 2 times a negative 1, and then the radical is just times that radical. Now, when I multiply the insides, they'll always match. 2 times the negative 1 is a negative 2 square roots of x plus 2. So the outside and the insides will always match. Maybe the hard part is the 2 times the negative 1 is a negative 2 times the square root of x plus 2. So we have, adding these together, we have a minus 4 square roots of x plus 2. Now, when we take the last times the last in this, you're taking a negative times a negative, which is a positive. When you multiply this radical times this radical, you have 2 of the x plus 2's inside, because you can multiply what's inside here. So you end up with, when you take the square root of x plus 2, this is the last times the last, you end up with x plus 2 squared when you multiply those. And if you have 2 of them, they come out as just x plus 2. Okay, they come out of the radical. We're going to clean up the right-hand side. We're going to isolate the radical, and we're going to square both sides again. So let's go through this. I've got 3x plus 4 equals, the 4 and the 2 give me 6, minus 4. So really, when you clean it up, the only thing you could do is add the 4 and the 2 together, and that's all you could do. Okay, now you need to ask yourself, we usually, see, I might move this over to the other side. Or we can go ahead and subtract the 6 and subtract the x, and then go ahead and square both sides. So we're going to subtract the 6 and subtract the x. Okay. Which leaves us with, because we're going to get this by itself, you can't leave that 4 times right there. That's gone and that's gone. I'm adding a piece of paper here. You get 2x minus 2 So now what you could do is you could divide everything by 2. So let's try that. Okay. Now that negative, you have to kind of decide about the negative. You could leave it there and square it, or you could divide by a negative and make that a positive and that a negative. But let's go ahead and let's leave it and let's square both sides. Okay. Let me see, where did I do? So quit. All right. So in doing this right here, this is x minus 1 times x minus 1 equals, when you square this negative, you're going to get a positive 4. When you square this, the radical disappears. Okay. All right. So now let's go ahead and square this. Okay, that came from this. Here you go. So we'll have x squared. Make sure you guys can see that. Minus 1 and minus 1 is a minus 2x. Negative 1 times a negative 1 is a positive 1. Over on the right-hand side, I'm going to take my 4 times everything. Okay, so now our next step is to set it equal to 0 because I have that squared. And we're going to end up with, I'm going to come up here, I might come way up here. I'm going to end up with x squared minus 6x. From the minus 2 and the minus 4 is a minus 6x minus 7. Let's factor it. Okay, now there's nothing in common, so we'll go ahead and x times x. All right, we'll have a minus 7 and a positive 1. Multiplied together give you a negative 7. Added together give you a negative 6. So we have two possible solutions, 7 and a negative 1. And we're going to try them both. We're going to check both of them. So let's go through our check now. Here's my original. I'm going to write it down. X plus 2 plus the square root of 3x plus 4 equals 2. Okay. Now, we're going to put in a 7 for our check. We're going to put in a 7, so we'll have 7 plus 3 times 7. Okay. The square root of 9. 21 plus 4 is 25. Okay. 3 plus 5. And 8. Therefore, 7 is not a solution because 8 does not equal 2. Let's go through this same process. Rather than putting in the 7, I'm now going to put in a negative 1. So here, I will, sorry about my dog. Let's see, where were we? Okay, so I'm going to put this right here. We put in 7, it didn't work. Let's put in a negative 1 now. So that gives us a negative 1 plus 2. 3 times a negative 1. Negative 1 plus 2 is 1. Negative 3 plus 4 is also 1. 1 plus 1 equals 2. So negative 1 works, whereas the 7 does not. Okay, and again, you know, probably this right in here, for going from this to this may give you a few issues. You just have to try it. All right, that's it for this section. It's it for this chapter. I'll open this up, and if you need more help, you know, squaring a binomial that involves a radical, please let me know, and I'll go through a bunch more examples with you if you need it. All right, otherwise, I will open this up and I'll publish the notes. All right, thank you. Bye-bye.